Welcome to the Grow 124 session at IETF in Montreal. This is a picture I took when I was running. I recommend all of you to start running. It's good for your health. It's unrelated to Grow, which is what is nice about it. Next slide, please. We are at an IETF session. This is our Note Well. There are two key points to this Note Well. One is that we strive to be excellent towards each other. So no arguments based on the person, but arguments based on technical insights. Let's try to be a polite debate club. And your contributions, the questions you ask, the comments you make at the microphone or to the mailing list are considered IETF contributions. And if you want to read about your rights and privileges, see these documents, please. If you have any questions about any of these documents or any hypothetical scenarios, always feel free to talk to us as chairs or to the area director. Matt, where are you? Yeah, that's our area director, the one with the sunglasses. Or is it sunglasses? No, normal glasses. Next slide, please. Today, we have a little bit of BMP on our agenda. Are there any things that should be added to the agenda or any other last minute changes that people would like to share? No? All right, then we're going to start with our presentations. I would like to invite Narashima Prasad.
I think Prasad is remote. So.
That's all good.
Oh, and the minute taker. We need a minute taker. Do we have a lunchtime? No, we don't.
Secretary would miss it.
Yeah,
we are looking for a volunteer to take minute notes. Do we have a candidate? Usually I would appoint Warren. So I guess maybe we can ask Matt. Matt, you want to take notes? No? Maybe Luke? What about you?
No, he has to present.
Great, yeah.
Paolo, do you want me to share?
I have your slides here somewhere.
Okay.
So I will. Why I don't find the slide?
Upload manage slides.
So Prasad, you should have control of the slides.
Yeah, I do. Thank you. Yeah, hello everyone. I'm Prasad. It's early in the morning here. It's 3:30. So I'm sorry if I'm a bit slow to get some of your questions. So I'll be covering 4 drafts. The BGP BMP generic event notification draft, common route monitoring across reviews, multi-peer header, and aggregated route monitoring draft on behalf of my co-authors. The first one is the BMP generic event notification message draft, co-authored with Tarek and myself. I think Tarek is in the room somewhere this time. Hi, Tarek. Uh, So just a quick recap on this. At IETF 122, we had proposed a new message type to inform the BMP collector to purge a certain review for a given AFI-SAFI. After that, we got good engagement from the working group and we heard about other similar use cases, other/similar. So we saw a need to expand the scope of the draft. And so in the last IDF at 123, we proposed introducing a new message type, which is the BMP generic event notification message type to handle such use cases. So the primary motive was to use this message type to notify the collectors of some diverse event which could involve policy triggers, administrative interventions, and such. This will help us avoid overloading other existing message types. And then just to note that for anything route related, route specific, we have another draft, which is REL draft, route event logging. I think that is what is a better way to go about. This one is something which is not route specific. So since we got support for the above proposal from the last IETF, we've gone ahead and updated the draft with the gen message type. And then we've also defined 3 events and use cases which we got from the working group. So this is the gen event message header. Basically, it has an event type, it has flags, then it has timestamps, and it has event subtive LVs, which are optional. So the 3 use cases we have defined with the 3 types 0, 1, 2 are one. First one is the review unmonitor event. This is the original rip purge use case we had. It is essentially an event sent when a particular review is no longer monitored on the router. So this could be globally configurable on the router. So it could be one event across all the peers, or it could be for a given AFI-SAFI, or it could be for a given BGP peer. It is entirely flexible and it just depends on the configuration option supported on the routers. The next one, which we got, I think one of the use cases we got from Jeff Haas was route import complete. This will be sent when the import of routes is completed on the router. So this could be again a global event, or it could have further filters at a AFI-SAFI level. And then the third one we got from Luke is to notify when a peer is configured on the router, but it has been down. So there is no peer up or peer down sent for this. So he mentioned that it will be useful for the collector to know about such peers. The downtime would be something configurable on the router. So now I'll quickly go through the event sub-TLVs. These are optional. So we have defined 5 sub-TLVs. So the first one is the obvious one, which is either a reason string or a reason code for 0, 1. And then there is a review filter. Type 2, type 3 is the route distinguisher, and type 4 is the peer address. I'll go through that in the next slide. There is string, and then there is reason code, and then for the review filter, this is essentially when you want to. So we have categorized this into 2. So one is just the context. There's additional context given to each of the events. Then the next 3 are essentially filters, which means this event applies only to this subset of things. So for example, in the review sub-TLV filter, we could indicate that this particular event is applicable only for in pre or in post. And then that is essentially the motive of it. Just a quick note that something similar is also defined in the common update draft, which I'll go through next. So we want to sort of leverage that. And then there is some discussion going on in the working group about this already. The next 2 filters are RD filter and the peer address filter. So RD filter can be used by itself, or it can go with RD plus peer address if it's a VPN kind of peer. So these are the sub TLVs. So I'll give you some examples so that it kind of becomes clear. So the review unmonitor event with a filter for review is what we have shown here. So this is the event type, then there is a timestamp, and if you see, there is some text about the reason code, and then there is a filter to indicate that this applies only to ADJ about 3. So this means at a global level across the router, we have stopped monitoring for ADJ about pre, so the collector needs to be informed about it, and then preferably it would purge or it can mark it stale or whatever it. I mean, that we've not defined, but the preferred option is to maybe purge because this is no longer getting monitored. The other one is route import completed event. This one we have shown with no filters. It is just the event by itself, that the route import is completed across all AFIs across all tables. Then the third example is peer configured, which has never come up. Hopefully, with some operational configuration option on the router, let's say 10 minutes or such. So the event basically tells you for a given RD and a peer. So we have indicated the RD filter, plus we've also indicated the peer to sort of tell the collector that at this particular event, this particular peer, which is L3 VPN peer, has not come up in X seconds or whatever. So um, that is sort of the gist of it. And then as next steps, I wanted to get some thoughts from the working group on if there are any other use cases events you would like to add. Please do share. As you can see, the event structures are generic and extensible, so we could add to it. And specifically on the peer address TLV filter, since the peer address is optional, and we found the peer header to be bulky for our use case, we have just defined a new TLV for this. But this is something I would like to discuss with the authors of the TLV draft to see if we can sort of make the peer header less bulky. So I started a discussion with Paolo on this for the TLV draft, but that is sort of one thing. And then we also want to sort of see how we can leverage the multi-peer header draft and maybe the timestamp TLV draft if possible. Thanks to Luke for the review of the current draft. We have actually updated and incorporated his comments this week. From him. So we would want to request working group adoption because we have had interest and we have incorporated all the comments on the working group. Yeah. Any questions? I see Thomas is there.
Yeah. Hi, Prasad. Just one question on the unmonitored RIP event. How do you when it is being used, and how to distinguish between the BMP peer down? I didn't quite understood the differences between the two.
Yeah. So sure. So the review unmonitor is we could have a global config on the router wherein you would enable different reviews, wherein you say express interest and configure saying I want to monitor, let's say in pre and in post. And then you go on a per peer basis, and I mean this depends on each implementation, but just taking an example, then you would go to each peer and maybe say I want to monitor this particular peer for this particular BMP collector. So in this specific use case, the selection of the reviews at a global level. So if someone goes and unmonitors, let's say in pre, today there is no event sent because there's no option for us to do it. So that is when we would send the gen review unmonitor event without any filters. We would say that in pre is unmonitored for the router. But let's say some implementation has per AFI way of configuring reviews, then you can also indicate that only for this AFI we kind of stopped monitoring this. So in the peer down, the flags are ignored. So there is no way to know for if it's a particular view or not. And then when we discussed in the last couple of IETFs, I think people didn't prefer overloading peer down because it is not really a peer down, it is this. And then there is a reason 5 in peer down, which does provide an option to say that peer is unmonitored. But we also wanted to cater for cases where it is not specific to your peer. It is like global for the router.
So if I understand correctly, basically you're making a distinction between whenever a peer goes down or whenever we are no longer monitoring that peer or that RIP, right? In my memory, like today, I think in implementations, when you unconfigure, then it's a peer down is being sent, but I need to review the normative text in RFC 7854 on peer
You're
down.
right. You're right. There is peer down reason 5, which is used for a per peer unmonitoring today. But the RFC 7854 errata has been updated to say that the peer flags are ignored, which means you don't have a capability to say a specific review is being unmonitored. It is for all reviews. So that is one shortcoming of it. And then secondly, it is always per peer. There is no option for us to say at a global level, at a per AFI-SAFI or at a router level to say that we are no longer monitoring. So yeah, it kind of covers that.
Okay, understood. Thanks.
Thank you.
Maxence from Insalion. Can you go back on the peer address TLV, please?
Yeah.
Yeah, okay, great. We have a document currently which, 'cause you said it's optional, right, at the moment, because of lock RIP peer types, where it's set to 0, basically. We have a document that tries to define a TLV with the peer address for the local RIP case.
Okay.
And so one feedback we got when we tried to define that TLV was that for IPv6, for example, sometimes you have link local addresses. And so you need to specify the interface name or ID or something like that, right? So that's something we're doing. Would be nice to like sync on that and have the same format in both our TLVs, maybe.
Sure. Yeah. Thank you.
Thank you.
Hello, Maria from BERT. I'd like to ask you, please, for adding sub-TLVs for either a port or probably some string description, not the reason, but description configured for the peer, because I'm in a situation where I can define connections for the same peer like 7-10 times with e.g. different local addresses, local ports, or other things, or have even several instances with completely the same configuration, and just switch them up down because of different, for example, filters or add path or something like that. So for me, the peer address itself is like completely not enough. And this is actually the same problem I have with the BGP Young as well. So please think about something best distinguishable of the peer. Thank you.
Okay, thank you.
Prasad, you can.
Paulo, can I go, or we are running out of time?
Yes, go ahead.
Okay, I have some quick questions. Can you go to the slide where we had different message type? I had some
Mukul,
questions over there.
Okay, can you take these questions to Prasad offline because we are going over time already?
Okay, sure. I will send a comment. Thank you.
Thank you. Thank you.
Thank you. So this one is common BGP route monitoring message draft, co-authoring with Dhananjay. A quick recap: at IETF 122, we had proposed a couple of ways to extend the route mon message to be able to combine route mon messages across reviews. And then we got some feedback on the options we had proposed. So at IETF 123, then we proposed going ahead with the common update TLV option, along with why we chose that option. So this is the TLV we have defined. This will be attached to the route mon. Essentially, there is IJOP bit for each of the modes, and we turn on these bits to say that which of these reviews are getting shared in the route mon message. So at 123, we got some comment. We got support for this, so we went ahead and modified the draft to indicate this. And then also another comment was to update how this draft can be used along with the aggregated route mon draft. So we have done that. And then I think Thomas also had a specific comment about timestamps, because we're kind of coalescing things, so he wanted to see how we can maybe have timestamps as well when required. So the updates we have done to the draft is we've updated it with the chosen option. Then we have also indicated how it can be used along with the aggregation draft. And then we plan to leverage the timestamp TLV draft for this whenever we need timestamps to be separately indicated. So one discussion is we want to have with the working group maybe offline is how to combine the review TLV, which was defined in the previous draft, and this. I think one of the challenges is the namespace. This again is being discussed on the working group mailer, so we will take it further there. We also want to request working group adoption for this draft as well, because we have incorporated the feedback, there is interest, and then it does help with the performance. Okay, I'll go to the next one. This is a new draft we have written for BMP multi-peer header, co-authoring with Yusong, Chang Wang, and Mukul. So some of it was part of the Route1 aggregation draft, but then we saw a need for supporting multi-peer header for other message types. So we kind of made it its own and then added the bells and whistles to it. So we had proposed going ahead with this kind of an option at IETF 123, and then there was no opposition for it. So we have introduced a new message type, which is multi-peer header type. The messages from multiple peers can be combined into one or more across message types. We've also added support for wildcarding of peers. There is also allowance for custom extensions per message type within the multi-peer header. And then the next draft, I'm going to talk about how this draft is leveraged for Route1 aggregation. So this is the main idea. There is the common header, then there is a common multi-peer header, then there is common information which is pertaining to all these peers. So that is, I'm expanding on the yellow section, which is there in the overall BMP message here subsequently. So then there is a common multi-peer header, then there is a TLV, essentially for the multi-peer header itself, and then the individual peer headers are called out here. So there is an individual peer header, and then following that is the length and the per peer information. So anything which is maybe different and cannot fit into the common one can be called out here. Some of this may become clear when we demonstrate how we have used it for Route1. But essentially, something which is not common and separate can go into the per peer information. And then anything which is common, we just list the peer headers here, and then we list the data for that at the end. We've also defined a wildcard peer header. Essentially, it is the same as the BMP per peer header, but we have introduced a peer mask to allow for some wildcarding. But this is just a start. More could be done here. So this also, I'll talk about it in the next slide. So one thing is, if you see other use cases for the multi-peer header, please reach out to us. We will show the Route1 use case in a bit. One question we had was, can we replace the existing V3 peer header with the wildcard peer header, not as it is in this draft, but maybe with few additional changes which I had in mind. Paolo, I've sent you an email about this, indicating if we can include this in the TLV, because this will need a version bump, and maybe this is something we can discuss and get back to the working group about. Because this will be beneficial not just here. We can define it in the DLV draft and then use it in this draft. Also use it maybe if possible in the Gen draft, because Gen draft also has a per peer header. And I think Max also brought up another use case for peer header. Maybe we can see if we can incorporate all the use cases and define one. So we would request feedback from the working group on this. Yeah, I mean,
I see
any
Thomas.
questions?
Yeah, hi, Prasad, Thomas here. Just one feedback. We have from Maxence a document where in local RIP today the peering address is set to 0, and he wants to set that on adjacency RIP in. And I think here we have a potential overlap between the two documents, because in your case, that is already solved. We would have seen basically at adjacency RIP and at local RIP with the multi-peer header that update, right? So I think in the working group, we should consider whether we want to drive both documents or we choose one over the other.
Sure.
Thanks.
This is Maria again. Personally, from an implementer, I would prefer having less drafts and more comprehensive RFCs, so I could look into one and not look into 4 different documents and find out how these are actually interconnected, which is especially true if you are not doing it right now, the implementation, but if you are doing it after 5 or 10 years from the perspective of completely new BGP demand. Thank you.
Sure. Thank you. Yeah, I agree with you. Yeah. Okay, that's great then. So maybe we will continue the discussion and then get back to the working group and discuss more. I think this is good. Okay, last draft on the Routmon aggregation, co-authoring with Yusong, Chang Wang, Mukul, and myself. So this was already presented at IETF 119 and 120. In the last IETF, we had multiple updates which we had shared. The main idea is aggregating Routmon messages across peers because it gives us convergence benefits. So one thing which we had proposed was to have a separate multi-peer header and then incorporate that in the draft. So you saw the multi-peer header earlier. And then in this, we are mainly, the main change is to leverage that here. I'll show you examples in the next slide. So essentially there's a common header, which is a multi-peer header. And then following that, because this is a Routmon, there is BGP update, PDU, and path attributes and prefixes. And I've just blown up the common multi-peer header here, which you saw in the previous draft. And then there was feedback from Luke on the previous version of the draft. So we have, thanks to Luke, we have incorporated that in this revision. So these are some examples which give you some idea about how the multi-peer headers is used. The first one is the best case scenario, where all your path attributes and prefixes are kind of shared with all these peers. So I've shown 3 peers here. So you would have the multi-peer header and then you would just indicate the 3 peers. This is just an example, but this could be hundreds of peers. Basically, there is no per peer specific part attributes. Everything is shared. All the prefixes shared. This is where you get the best benefit of the draft. Then as you go to the right, there is one case where only peer 1 has its own path attribute. So if you see here, there's a per peer path attribute, which is indicated. So anything which is outside of the common can go in there, but it is still shared. Whatever is shared is still shared across all these peers. And then this is another example where each of these 3 peers have their own path attributes. So it accommodates that. So this is where you see the per peer info. And then there is update, PDU, and path attributes. And then the last use case is where there is no shared path attributes. I would suspect this not to be a good use case for this draft, but if somebody wants to, they could still use it. So there is per peer and each of the peer attributes is mentioned there. And the prefixes are also shared. Yeah. Yeah, we would request any further feedback and review from the working group. So we've got good interest and we've accommodated all the comments. So we want to request working group adoption for this draft as well. That's all I had.
Hi, Prasad. This is Luke. First of all, thanks for all the updates at this hour. It's much appreciated. I have a request and a comment. I've read this one and I've read the previous one with the multi-peer header. I think I understand what you're trying to do, but it's a lot. So I think it would be really valuable if you and the other vendors would provide PCAPs with unaggregated route monitoring and aggregated route monitoring stuff for the implementers of collectors eventually. So we can really make sure this works between all the implementations of the vendors and all the implementations of the collectors, because I guess this is worthwhile. doing, seeing the author list, but I think it will be really tricky to do this correct for everyone. A question about, if you can go back 1 or 2 slides. The next one maybe. What about TLVs? We put a lot of effort in making all the message types TLV capable. I don't see TLVs here. The BGP update is part of the BMP PDU, if I interpret this correctly. Are TLVs still supported? Do you leave them out on purpose, or what's the deal?
TLVs, you mean like other TLVs which go with Route1, they can continue to go with this. There is no restriction for that. If you're referring to the V4 NLRIs, are you referring to the what we have defined in the TLV draft?
So, for example, stateless parsing.
Yeah, so that is the V4. Yeah. So, sure. I mean, that is maybe something we can add and clarify in the draft how it could be incorporated. So right now it is with the V3 version. So we can also indicate how it will work with V4. Sure. Thanks.
Okay. Thank you.
Yeah. Thank you.
Okay. Thank you, Prasad.
Thank you.
Thank you so much. I just comment on what Luke was saying. I second what Luke was saying. And also on your presentation, I saw like that on the first one, there were a very nice layout of use cases, right? But then in the others, there are the ideas, but probably I missed a little bit the use cases, and that probably goes a little bit hand in hand with what Luke was saying, to make this a little bit more tangible with the pickups, with the examples, with the use cases and things like that. So if you can put a little bit of work, you and your co-authors, on this part, on what we are trying to solve, what would be our achievement rate and things like that.
Yeah, so some of that is covered in the draft. Maybe I can summarize and send it to the working group so that it's useful.
Sure.
Yeah.
Thank you, Prasad.
Thank you.
Tobias. Yes.
And it is prepared for me. Nearly. Good. Any introductions? Can I take it away?
Please.
Awesome. Thank you. So it is me again. Hello. Your 3 most favorite drafts that are not about BMP in this working group and adopted at the same time. I think there's one other that's not BMP. And it's worked together with Nick Elliott and Wolfgang Tremmel. So about the first one, that is the informal routing security update, which means all the technical implementation details, which we wanted to take out of the main document for policy. What has happened since the last meeting? I thought I've summarized that in French, given we're in Montreal, with the words of Louis XVI, Rien. That is no longer fully correct, because just now I got an email from Jeff, which had a lot of really valuable input, which I'm really looking forward to implement. And he also had the good idea of maybe doing a little bit of a hackathon or something, maybe not in Shenzhen, but maybe in Vienna, to get this document polished. And I really like that idea. So the plan there for the future is getting through that feedback, implementing it, and then maybe planning a bit of a hackathon in Vienna. So yeah, to do is basically still the same thing as well, plus minus what is in the feedback from Jeff. Next one, this is the terms draft. It was our little French dictionary. So as it is tradition then, also in French terms, there was also not much change, because I ended up having a lot more day job than I was planning to have. It is still or plan to have this not like in DNSOP as like a prescriptive, this is how you talk about routing security and, well, routing operations, not only security. But instead be like, this is how we do it at the moment. Your mileage may vary. It should be continuously updated. And well, I'm on it, and I promise for the next meeting, well, not the next meeting because I won't be in Shenzhen, but for the meeting after, there will be some form of tangible progress. Now, going beyond that, there's also a CERT document for which I also received some feedback this morning, which changes a bit what has happened. So the original plan for this document was to replace RFC 45, I think. I'm really bad with numbers. Anyway, what is currently in BCP 194. To make that a bit more recent, after some people told me that they don't like to have their IX prefixes announced. We tried to simplify that. So this is also the source of the informal draft, because originally it had like all these 50 pages of text. Given that we are currently struggling to find people reviewing it, now that it has 5 pages, I kind of imagine what would have happened if we would have tried with the 50 pages. And what changed since the last meeting is some minor formulation changes, also recommended by our AD. And we got 2 reviews from directorates and addressed these comments. For routing directorate, there was a major comment to rephrase our definition of like what does it mean for an AS to be authorized or an AS path to be authorized. They helpfully provided formulation for that, and we just adopted it. There was also a minor comment on section 3.1 to add further references, and we also did that. Indirectory basically said the document is ready. Suggested a change in the title, which we happily implemented. There were some comments about wording in the abstract, but these had to be rolled back. And there was a comment on our use of host versus node. I don't have any strong feelings about that, so I just went with the suggestion. So, discussion, and I think that is what we will use most of the time, hopefully, for, is, well, for the OPSEC informal document, I received a lot of feedback. I would really appreciate it if some other people than Jeff would also provide that amount of feedback, because then this document will make a lot more progress. You can also directly send pull requests. I also take those. It doesn't have to be feedback in an email, but like at least the feedback in an email would be really great. For the terms draft, it's basically the same thing. We're still in front of the open question: how do we cluster this alphabetically by topic, etc., etc. Do we deal with TLAs in a dedicated glossary, or do we leave that integrated? The most interesting part is the BGP Grow BGP OPSEC update. From the reviews we got before the meeting, we addressed the comments. We still believe that it is ready for working group last call. There is some feedback now from Jeff, which I believe is no major change to the document. And what I would like to ask is, once this feedback has been implemented and the new revision pushed, that this revision goes in working group last call. Thoughts, ideas, disagreement, or maybe agreement, but don't, like, I'm not used to that.
Hey there, this is Daniel speaking for DCakes. You're asking for agreement. I'm here to give it to you. There's been a Ripe Labs article published recently that shows how fragile things are with the BGP IXP prefix and how to deal with that and what not to do with that. And I do see the changes are in there. They are highly needed, so I appreciate want the working group to move forward with the working group last call. Thanks.
Anyone else?
Your request for working group last call has been noted.
I'm not sure whether anyone else heard that.
Your request for working group last call for OPSEC update is noted.
For the soon to be pushed next revision. Thank you.
Thank you, Tobias, for the efficiency as always. and Daniel.
Is this my clicker?
Yes.
It will be in 1 minute.
All right. So as you're all waiting, I'm Daniel. I'm happy to have made my way to grow, pun intended. I'm sorry.
I don't find your slides. Yeah, I found your slides.
I'm good.
Please take it away.
All right, cool. So there's a thing I wanted to bring up in this working group. It is the BGP next hop translation of IXPs. This is joint work together with Maria from BIRD or ZZ Nick. And to give you a bit of a background, this is the 00 version, so first try, let's say. I wanted you to have some background information on what this thing is all about. We've got this very neat RC 8950 out there. Yay. So what's cool about that, you can do some things, for example, like run IXPs on v6 only, which is a cool thing because as we're running out of v4 addresses, there's, for example, the RIPE region that have this RIPE 826 in place that was decreasing the standard allocation size for new IXPs, so you get a /26 instead of a /24. And in the best case, you don't need any IP addresses, v4 addresses anymore. But well, if you have a v6 only IXP, you don't have to renumber anything anytime. This is great because renumbering is a big pain for IXPs. So yeah, there was a working group that founded at the URIX that found out that not all BGP speakers in IXPs do support RC 8950. Well, so we're looking into this. And first of all, wanted to have a coordinated transition or sort of a plan to just migrate all the peers to v6 only and to give all the members of the IXPs the configuration snippets they need. So wanted to make it as easy as possible for them to transition to v6 only. And as a side product, we got up, we got a list of vendors not supporting RC 8950. It's all on GitHub. You can go ahead, look it up. And that's a problem. So instead of approaching all these vendors, there are a few, you can look it up. We decided to move forward with our own solution because that's much easier for us to control and deploy and quicker and whatnot. So yeah, this is maybe why we're here. So as said, this is a problem statement just in brief. This is a roadblock for v6 only deployments at IXPs. The question is, why do we need an RC? Well, okay, first of all, there's RC 7947 that basically says that route service must not rewrite next hops, and spoiler, spoiler, this is what we're going to want to do, so we have to update this. Next thing is, if we have an RC, we have one way done right for all of them, because all the IXPs that have vendors in their peering lands not supporting RC 8950 have the same problem. So yeah, we want to have one solution done right. All right, next up, getting to the meat. What is actually in there? I need to bring up a few. In the RFC, we come up with a few terminology, some words that we want to introduce. These are legacy, supporting unnumbered speakers. This is sort of going through the whole document like that. And then, as said, the main idea what we want to do is to set up a BGP ARP ND snooper in the peering LAN that translates the next hop addresses based on a SLAT. So what's a SLAT? A SLAT is basically a lookup table for the translator. This is going to be some device, spoiler, spoiler, can be the route server. And we're basically building upon the fact that every peer has a MAC address, and we are going to assign them some very nice v6 addresses that we can use. They come in different flavors, the ones you know. And then to the right of it, what's interesting now is a click, so-called customer-specific local prefix, CSLP. And these are the prefixes we're going to negotiate with any legacy speakers, those that need IP version 4 for BGP. We're going to assign them some nice prefixes. This is a proposal. I'm happy to have any discussions about that. that will be used for translation for the rest of the peering line. So this is basically the mapping we have. Using this mapping, we can translate next hops. Preferably, we don't have to, because everybody's using V6 anyways, but this is unfortunately not the reality. Not yet, but we're getting there, hopefully. All right, so then, some facts about the CSLP. This can be the same for different legacy speakers, and preferably, we're going to get all the legacy speakers into the same prefix to keep the slat small, so we can share this. All right, but it can be any v4 prefix from anywhere, basically, with the only requirement that it just doesn't conflict with what in the IGP of the peers is happening. And of course, it should not be globally routable, because we do not want to have our prefix lands somewhere in the world and open to the Wild West. It's nothing we want. So we want to have something preferably that is not routed at all. There are a few prefixes around. Yes, I know, but we can't really tell for sure if they are not already being used by any of these legacy speakers. So in the best case, and this draft currently does this, we get a /8 from some reserved range, and this is what we in the draft refer to as the IXP interconnection space. I know this is hard to get, but okay, we start big and we see where this is going. We're still happy with a preferably small number of different prefixes that we can negotiate with all the peers for use for their translation then. And in the worst case, we're hitting at least one legacy speaker that's unable to use any of the prefixes because they got all of them in use in their IGP or somewhere else, or they can't configure, or they filter, or they just don't want. I don't know. All right. Speaking more about technical stuff, some IXPs already do things with EVPN, for example, ARP and neighbor discovery snooping. This is because we don't want to have any traffic in our IXPs. And it can, in theory, also do the BGP next hop translation. There's actually BKX, Andre Grünenberg from BKX is doing or looking into this. It's sort of different side thing that he does. It's sort of different, but the idea is about the same. So it could be done in the edges as well, but somewhere that a translation needs to happen and somewhere a slat needs to be around. This draft also comes with a bunch of security considerations. So the snooping gives us some security and control. The MAC address registration next hop translation should be checked by the IXP periodically and automatically, so we are not passing out some weird information and stuff like that. We can detect if some of the peers have misconfigurations there, so it's more on control on our side. And yeah, if anything breaks, well, we can just drop anything that's broken. So it prevents some propagation of broken things. So this is just something to start with. Also, we come with some operational management considerations. Main thing being is that we need to have a step-by-step rollout for existing IXPs. If you build a new one, just don't use IP version 4. Bold claim, I know. Yeah, if you then there are a few things that can happen sort of independently of another, so snooping can be enabled right away, and then we need some kind of agreement on how to do the translation. So this draft is then the thing that would be coming in. It could be a new route server, it could be the old one, it could be a dedicated snooping device, I don't know. And we can use as the first CSLP the current in practice or in operation IP version 4 prefix. This is something we can do, so there's no renumbering at all, and it looks to the outside as nothing has happened, but okay. These things are running out of addresses soon, so we are in need to get some new prefixes for these customers. And this is something we can negotiate then afterwards. There's another operational consideration. Briefly said, what do we do with some of the peers that are legacy speakers and just don't want to use the route server? Or whatever device is doing the translation, please get a v6 address. Thank you. That's all I can say at this point. And yeah, we want to publish the slat so everybody can look up the things themselves, like on some looking glass extension page somewhere there in the web. So this is transparent, hopefully. And if any of the peers do not want to use the route server because they don't want to have visibility in the looking glasses for their routes, we encourage them to come here anyways and tell us how we should hide their announcements to the public. As said, there's an IANA consideration as well, looking for some large block, but we can discuss this. Then I think that's it already. We've got a few to-dos left, and the most important thing is a request for adoption in this working group. And now I'm very happy to take your comments.
Tobias Siebig, Max Planck Institute for Informatics. And first of all, I would like to donate my 5 efficiency minutes to the mic line. Overall, I support adoption of this draft. I'm a big enthusiast for 8950. I'm also doing things in this direction already in, well, not really production, but you can try it on the internet and test it. There are a couple of terminology things I kind of dislike in the draft at the moment. Use of unnumbered, is it really unnumbered if it has a V6 number?
It has a number, yeah, right.
And there's some funny double negotiation. And I personally am not really a fan of doing this with like ARP ADP proxying, but prefer injecting routes. But that also comes with caveats. But that is, I think, something which needs to be discussed in the lifetime of this draft.
Very cool.
But definitely supporting adoption.
Thank you very much. We'll look into that. Thank you. Hi, Jeffrey.
Hi.
Yeah, he's tall.
Yes, very tall. Jeff has. So the 240 thing may cause you a little bit of grief. IANA is really not assigning stuff out of that. And even if they did, there's a lot of providers that are happily using it right now.
I know, yeah.
So I would take some caution there. One other thing that's worth thinking about is stealing 169.254 from the DHCP range.
Yeah, right. I had already some comments out there on the streets. I might have actually had a look into that and should update what it said on the slides. But yeah, this comment always brought to the table. Thank you. All right. Thank you.
I mean, I like the modest proposals, /8 between friends. That's, yeah. Okay, what do you want, Luke? /7?
I want these slides is what I want. Perfect. It worked out. Okay. Hi everyone. This is an update to the BMP offline draft, which we retitled again to keep things exciting. Also because snapshots is actually the better word for what we're trying to do here. I will do a recap in a second, but the main thing that changed from the previous version is that we really pivot away from doing this between the router and the collecting station, because that seems to be too expensive to do. So the motivation is moving towards doing this from the station onwards to either the next station or to persistent storage. And what it is that we want to do is we want to have something that can represent the full state of what's currently in the monitored router, right? We have this initial sync thing where we get all the peer up notifications with the session information. And then the route monitoring messages with all the RIP contents, but it's only at the beginning of the session. So if for some reason you have to tap into a BMP session midstream, you miss all that stuff. And a BMP snapshot is here to help you out there. This is not one large single message. It's really a collection of messages. And it looks like this. So if the green things are the peer up notifications as we know them today, and the blue things are the route monitoring messages as we know them today, we're adding the purple stuff. That's one message type. That is the snapshot message that we use to signal the start of the snapshot and the end of the snapshot. Those can contain TLVs to add some metadata to the entire thing. And then all the messages that are part of this snapshot will have a snapshot ID TLV attached to it, right? So everything that carries the snapshot ID TLV is part of your snapshot. Now, we can send this on to another station. You can put this on a message bus, or you could use this to store things on persistent storage, which might not fit on floppy disks, but hey. So the cool stuff, this is all still in protocol. So even though I said we're pivoting away from doing this between a router and a station, that is still possible if you want to do it, right? And this also makes it very flexible and extensible, because if we want to add another message to a snapshot, another message type, we only have to add the snapshot ID TLV to it. Hence my question to Prasad, can we also use TLVs in an aggregated route monitoring message? So this is, in that sense, quite future-proof, we think. Now, on backwards compatibility and incompatibility, we added some text on what can break if you send a snapshot to a station that is not aware of snapshots and has no functionality implemented. The snapshot message is optional. The snapshot ID TLV is also optional. So if you have no clue what it means, you simply ignore those, right? But what you then see is basically a bunch of pair-ups and a bunch of route monitoring messages. The problem there is that you'll get a pair-up for something that you already consider up. So what are you going to do? And this probably will be different per collector implementation. The same for route monitoring messages. You will get a route monitoring message for something that is already in your state, which might not alter the state, but depending on your implementation, it's maybe a signal that you don't expect. That's a problem. On the collector side, we also got some feedback in the last hour about the sending side of things. Like, how should we handle, while you're serializing the snapshots, new information coming in? What happens when a new update comes in while you're serializing this snapshot, right? That's something we still need to figure out. Some workarounds for the case when you don't support snapshot at all, we could think about dropping everything with a snapshot TLV, but then you still need to be aware of this concept of snapshots, so that's not great. We could introduce a flag in the prepare header, but that seems kind of wasteful. And I just had a chat with Maxence earlier, and maybe a better workaround here is just encapsulate the entire message, so a pair up or a route monitoring message, as a TLV in a new message type, our snapshot message type. So at least if you don't support snapshot messages, you just ignore the entire thing anyway, and it's not reduced to a pair up or a route monitoring message causing you problems because you've already seen such a thing before. Another new piece in the text is the error TLV. We now have text on the end of snapshot, and we think it's a good idea to add an error TLV there saying, hey, for some reason, the snapshot that you are currently receiving is incorrect or incomplete or whatever. It stops here for this and this reason, so that the collecting station knows there will be no further data. We're also on the fence whether or not we should make a mandatory TLV that actually explicitly signals success versus failure, but that's, I guess, a small detail at this point. Another thing that is a discrepancy, if you compare this to an actual initial synchronization as we know it currently in BMP, is we do not include any EORs in the snapshot. The final snapshot message already signals, hey, we're done here for all the RIP views and for all the address families. So I'm not sure whether there is additional value in including EORs, but it's something we should discuss. And then I guess we'd like to ask for adoption at this point. So maybe we can do that on the list somewhere in the next few weeks. This was not unexpected, please.
Yeah, you should not look afraid. Jeff, as the end of ribs, you do want them, partially because it is very likely that implementations are going to implement this using their backend for their route refresh infrastructure. So it's already going to be there.
That's fair. Yeah. Okay, and then we can go on to the next one, I think. Ha. Different template, again, keeping things exciting. This is a revived draft together with Colin. It's called MRT BMP. Guess what we want to do? We'd like to store BMP messages in MRT files just as we've been doing with BGP messages for decades now. It's a de facto standard to store and share messages. Large route collecting projects use it. They might also be interested in sharing BMP feeds. So we want to make MRT ready to support this stuff. Now, compared to BGP, we'd like to do some things a little different. We really only want to store BMP messages. If you're familiar with how we do things in MRT, for BGP, you have these things like table dump and per index table to have the actual state in there. And then there is the message type, which just encapsulates BGP updates and BGP opens, that kind of stuff. We really only want to do the latter, so encapsulate BMP messages. So we know what we want. When do we want it? Actually, Colin already wanted this 6 years ago, but folks weren't having it. And it was explained to me that the reason for that is that there was still a problem that we hadn't have any option, an ergonomic solution to do stateful parsing. As I guess most people in this room know, to correctly parse a BGP update, you will need some information from the BGP opens. For example, the 2-byte versus 4-byte ASNs, AdPath, etc., etc. Now, if we want to store these messages in MRT, we will also need that information to correctly parse it while consuming the MRT file. Now, how this is done in MRT for BGP updates, there is for every new thing a new message type, right? So for the MP message, we have an MP message underscore AS4 for 4-byte ASNs. And then when AdPath support was added, something that Colin actually initiated, we get this product of all the options, right? So we have one for the 2-byte ASNs and the 4-byte ASNs, and then with AdPath and without AdPath, etc., etc. And this is cumbersome, and we want to prevent this from happening again with BMP messages in MRT. So again, that's really why we only want to add 1 or 2 new MRT message types, which just encapsulate the entire BMP message. Because we can leverage what's already in the BMP message to figure out all that other stuff. So we have the common header and we have the per pair header. So what it would look like in the MRT file is basically this. We have an address family that says this comes from a V4 or a V6 collector. The addresses are there, and then there's just the BMP message. And I'm not sure whether it's visible, but the common header and the prepare header will have all the necessary information for us to then make sense of what is in there. And if we ever get new BMP messages, this will still be flexible enough to store BMP messages in MRT. So what about the stateless parsing problem? Well, the whole 2-byte versus 4-byte ASNs actually never was a problem because we have the per pair header, right? And as we store it, we can use that. Now with the BMP v4 or the BMP TLV draft, we'll get the stateless parsing TLV, which will solve all the other cases for us. We can do AdPath, multi-label, and anything else that will pop up later. So that should be okay. The only thing here is that if you read the current version of TLV, so that's version 19, it says if no stateless parsing TLV is present in a route monitoring message, the receiver must fall back to use capabilities present in the BGP open PDU contained in the relevant BMP per up message, yada, yada, yada. But I don't think this is what we want in MRT. I would actually propose to turn this around. Of course, we do need the context. But I would like to say that if you need extra context to parse something, the stateless parsing TLV must be there. So we don't require the MRT parser consumer to jump back into the file or to connect the dots with previous packets, and have a sort of default mode where you say without a stateless parsing TLV, we can have 2-byte or 4-byte ASNs, because that's in the per pair header anyway, but there will be no path ID, so we don't do AdPath, and there's no multi-label. So it's a vanilla PDU, if you will. And maybe we can argue what the default would be. But the reasoning is that while producing an MRT file, you probably have all the required state available anyway, so you can attach these TLVs to the message that will be written in the MRT file. And if you're consuming the MRT file, it's nice that you don't have to piece together all these messages. Giving you more performance, it's less error prone, and perhaps it's easier to also slice up MRT files in multiple files. So the relations to the other drafts, if we leverage the snapshots that I presented in the previous slide deck, we can actually put in an entire snapshot, and it will give us the same functionality as what the peer index table and the table dump did in MRT for BGP. So we can still create an MRT file with only BMP messages that has the same functionality as what a dump or bview file does, if you're familiar with the RIBRIS and the route views projects, right? So we get the full state, and after that can come the live updates. Again, just in forms of BMP messages. So my questions to you now is this worthwhile? And is this the right approach?
I'm in the queue. Jeff has, yes, it is absolutely valuable. We've been needing a way to serialize this stuff, for tool use anyway. Being able to snapshot things is also very helpful. I think my one bit of commentary, the mechanism you're using to do the snapshots up front is perfectly fine. That said, don't hook this too far into the use case for the on-the-wire resync. You are allowed to do something separate if it makes sense. And part of what I'll cite is from the original BMP spec, where the table dump is different than the update messages. They're very different PDU formats. We're looking for the operation of being able to get the pure state, how to parse the messages that follow, and then a dump that allows us to then resume the messages. And if it makes things simpler, go with the simplest possible implementation of that behavior, as if you're doing a brand new session coming up, as if you're snapshotting that, maybe with one new TLV that is just there that's to indicate that this is used for file purposes.
Paolo, as a contributor to the working group, I find this work very relevant and very useful. Maybe like I was saying before to Prasad, maybe we give for discounted the use cases, but there are some solid use cases for this, including, for example, like what we do with the pickup, like that we do where something is wrong with my implementation, we want to reproduce an event, and then what do we do? We share a pickup with a trace with each other. So this would enable us to do that. So there is all debugging, troubleshooting, and then historical events. You can make historical maps. You can do whatever, I don't know, a RIBRIS does, but with more information. So maybe all of this we can code in the text.
Hello, Camilo Cardona from NTT. I would say that I agree that there's an overlap between the files and the snapshots, right? I mean, we have discussed this briefly, because to me, having stuff in directories is like in a Kafka tree and having different topics. But it's really easy to have different topics in a file system because it's easy to have different directories. So the namespace doesn't match. So I will go for that, but I mean, we can do it. And of course, it's useful. We're using MRT all the time. So.
Okay, thank you.
Job, as individual contributor. I don't see a queue, sir. First of all, I think your slides look really nice. Well done. I think it's special that you share it with us.
Thank you.
And, yeah, it shows. Secondly, when you're encoding data inside other data, I imagine that these files are stuff that's going to be laying around for possibly decades, right? You'll start collectors and they'll make data available for many years to come. So thinking about file archiving robustness features, for instance, making it so that in the encoding it becomes clear if a message on an individual level was corrupted or that the whole archive is corrupted. Like, how do you, if bit flips happen, what parts of the archive can you repair or not repair? How do you detect corruption? I think it's worthwhile putting some time in that, because I think it was with large communities that there was a bug in a BMP in an MRT writer, and like that one write had an adverse effect on large portions of the archive file. And yeah, my recommendation is keep in mind repairabilities of the archives, add checksums or use length fields to make it robust.
Yeah, I guess that's a fair point. I also think that goes maybe beyond. I mean, that's an MRT-wide improvement that you're suggesting, right?
It really depends on what you put in. I mean, you can put a checksum per BMP snapshot into the MRT.
Right. Yeah.
Jeff, as Joop startled a memory out of the archives. One of the things that Merit used to use these MRT snapshots for its collection purposes was archiving bad packets, which we can't really do for route monitoring. And we've had prior conversations that for route mirroring, we don't have clean procedures for saving the bad things, and how saving the bad things in the data stream fed to stations might be hazardous. But dumping them to files is a great idea. But it does mean that we have to solve this problem. To the second point that you raised, I want to say, doesn't RIPE actually keep like SHA-1 indices in the files? It's been a very long time since I've gone looking, but certainly putting out a detached checksum would make sense.
For sure, they're wrapping things in a compression archive or making some hashes of the outer envelopes available is useful for some failure scenarios, but in-file corruption produced by the BMP collector also needs consideration. Like, how easily can you detect a corrupt writer and fix the bug?
Yep.
Long story short.
Good thought for turn. Yep. Thank you.
Repairability.
All right. And okay, there is a delay. Sure, it went to the okay. It's I was holding the other way around. Okay, that's why I was right. Okay, so BMP v4. What is the main idea? Just a super quick recap. It's the making TLV supported in all the TLVs in all the message types. So what happened between the last IETF and this IETF is that I merged the EBIT draft into the TLV draft. That is the main thing that happened. So there was a poll, if you guys remember, in Madrid, and people really wanted to see just one document out of the two, and so I did it. Of course, the document is becoming a little bit larger. It's not document with Yang, so it's not over 100 pages yet, but let's say still it's consistent. So a few things have to be refined on the corners as a next steps. There is some feedback from Dhananjay and Prasad that I have still to process because it arrived really recently. And the third thing happened during the hackathon last weekend, where I was discussing with Maxence about stuff and saying, yeah, of course, stats message is already TLVs and this and that and whatever. But then if you want to add, so if statistics are already TLVs and you want to add other kind of TLVs that are not statistics in a statistics message, then what do you do? I mean, how do you distinguish one from the other? So I think the simplest idea is just to have a stats container, you put all the statistics in a container, and then you can set other TLVs trailing in the stats message. Open questions. There will be a presentation later from Maxence about his other TLV draft, the flags, the timestamp, the sequence number. And so let's say open question there is does all of that or any of that belong to this draft, or we should keep them as a separate documents? And it's maybe not, it's good to collect opinions, not to make an action item for now, but it's very good to know what people think. Also because there was some request, for example, from Prasad already for a piece of this SNTS draft to go into the TLV draft. So open for feedback and comments. Thomas, please.
Hey, hi, Paolo. I would suggest to rephrase the question. There is section 6 in the TLV draft describing how the timestamp should be changed, versus in this document, we have basically additional timestamps in the TLV.
Right.
And I think we should choose one over the other.
I agree.
Yes.
I agree. I agree. And part of the motivation of this open question is, let's say, my initial motivation was essentially like this, that I left it to just almost a one-liner, the timestamp, like we need mandatory timestamps. And then Maxence came and did a full-blown job. And essentially, I think it's what we need, actually. So that was my original motivation.
Absolutely, and this matches perfectly what we have implemented in Yang Push. It's
exactly
the same.
Exactly. And this is what I was thinking, that by incorporating potentially this draft into the TLV draft, we are almost aligning.
Exactly, and we need consistency among the protocols. Yes.
Yeah. Thank you, Thomas.
Luc Hendricks. I was wondering, it was mentioned, I guess, in Dublin with regards to flags. Like, why don't we simply increase the size of the flags field as we're doing a version bump anyway, which I thought was quite a nice idea. I like my flags on a position in the packet that I, know where to expect them. But I haven't heard anything about that since, so I'm not sure whether I missed a memo or people are not a fan of it. But I guess it's something that we should decide on at this point, right?
Sure. And yeah, I myself, I would say like just one thing. If you do a TLV, you can increase it, as much as you want, and we don't go like from the current dimension to 2 times the current dimension, because then we don't want to waste space, and then essentially you have to bump the version again for increasing it yet again. And it seems that like we are selling these flags pretty easily these days, right? So it's they really are blockbuster.
Yeah, they're in demand for sure. But and I guess there can be, we can have both, maybe to a certain extent. Like I like we use flags as sort of a key thing, right?
Absolutely.
To distinguish between
Absolutely.
Views. I would still like to see
sure.
a hybrid solution there.
In fact, I tell you, this is my opinion, but I think you are totally right. This topic should not just be dropped on the floor. We should still discuss it. So
good. Thank you.
Thank you.
Yisung Lee.
Hello?
Quick connection.
Hello, can you hear me?
We can hear. Hear you. We can hear you. Thank you.
Can you give me the select control? Yeah, I got it. Thank you. Hello, everyone. This is Yisung Liu from China Mobile. Today, I will present this using BMP over quick connection on behalf of my co-authors, Chen Wang, Thomas, and Polo. Firstly, I will introduce the updates from last presentation. We have reorganized the structure of the multi-stream contactor, and the second, based on the comments received, we have added the description on the use and the selection of the multi-stream modes, and we also rewrite the solution with the control stream and as a use case. The third part is that we have updated the operational considerations. So firstly, we have reorganized the structure for the section 4 at the main section of this draft. And for the section 4.1, we have the multi-stream selection summary, and the 4.2 to the 4.4, we introduced the details of these three modes. For the multi-stream solutions overview, we have now, in this draft, we have three available solutions. The first one is that the per peer streams unchanged in this version. And the second one is that the per arphilosophy streams also unchanged in this version. And the third one is the multiple streams plus the control stream is modified mainly in this version. And all these three modes selection based on the P2P configuration complexity. And the key result of these solutions, one part is that without a control stream, in the section 4.2 and 4.3, and in these two modes, the initiation message must be the first on each stream, and the peer up message must be sent before any other peer BMP messages. The other part is with the control stream. In the section 4.4, the message ordering must be guaranteed. So with the control stream, we have provided the BMP channel structure, and the single BMP over quick CAT connection consists of one control channel and one or more function channel. For the control channel, we always use the bidirectional quick stream 0 in this slide. So we contain the message type, including the initiation, termination, peer up, down. And for the function channel, we use a UD rectilinear quick streams. The message type, including the route monitoring mirror and the statistical report. And the data frame here is that we have the control data frame. Compare the data frame in the function channel. We have in the control channel data frame, we add a field, the sequence number. So when the control channel responds the message, the sequence number matches the corresponding BMP message from the monitor router. And it will ensure the proper request response, correlation, and the synchronization. So for the control channel message, the initiation message must be first sent over the control channel. So the monitor router send other BMP messages only after receiving its response. So for the peer up, the waiting for the response from the monitoring station after sending peer up notification, and then we'll create the function channels using the redirectional quick streams. And for the peer down process, close all the related function channels after sending the peer down notification. So the response messages to the previous peer up messages for the same peer should be ignored. So for the function channel here, we have two types here. The first one is the per peer per Afio-Safi channel. For this channel, we transmit the statistical report message without Afio-Safi, and also including the router mirror messages. That will enable the separate transmission from the route monitoring messages, preventing impact on the routing monitoring message sending performance. And the second type is the per peer per Afio-Safi channels. And this in this type of channels, we transmit the message type for the status report message with Afio-Safi, and also the route monitoring messages. And we will organize by the Afio-Safi classification, like in this slide feed. Now we have a use case here with the control stream process. Like in the router A in this feed, he will establish a BMP over quick connection between the router A and the monitoring station. So here is a process detail here. Because the time is limited, I will not introduce the detail of this process. So the next is the operational considerations update. The first one is the BMP over quick protocol configuration. We think we should provide the configuration to enable the BMP over quick as the transport protocol for the BMP sessions. Make the quick transport configurable option alongside the existing protocols. And the second part is that the fallback mechanisms. So if the quick connection fails to establish, the monitor router should automatically attempt to establish the TCP-based BMP session, ensure the backward compatibility and the service reliability. The third part is the multi-stream selection. Implement the configuration option to select the preferred multi-stream solution. So that's all. We want to seek more feedback from the working group, and we also think we hope to ask us for the adoption code. That's all. Thank you.
Any questions from the group? All right, let's make a note for adoption.
Thank you.
Thank you.
Thank you.
Hello, everyone. Can you hear me?
We can hear you loud and clear.
Okay. This is Tangwan Lin from New H3C. This draft is about peer capability update notification in BPBMP. So we can see the background. Let's review the BP dynamic capability. It allowed BP peers to update capabilities without the session reset. It can avoid unnecessary session flaps during upgrade or enhance scalabilities in large networks. For traditional BGP, capabilities are advertised in open messages, and the session reset is required for capability modification. However, when BP supporting dynamic capability flashed, capability can be updated by BP dynamic capability message, and the capability update can be updated without a session reset. The related capability can be revised by BP dynamic capability messages, include MPBP load refresh or GR or long-lived GR, and so on. Currently, BMP does not support monitor of capability dynamic updates. So how BMP can monitors the BP dynamic capability updates. When BP session is up, BMP peer up notification message is sent once for the reporting initial capability to the monitoring stations. If we use the original peer up notification message for capability dynamic updates, multiple same peer up message may confuse the monitoring stations. Multiple same peer up notification message may be mistaken interpreted as a session reflecting or re-established by monitoring stations. Also, session reset will require the retransmission of all route monitoring messages and unnecessary increasing network load and additional bandwidth. So in order to report clearly BGP capability changes, we proposed two solutions. One is to define a new BMP message for that. Another is to define a new TLV in our available BMP messages. This new BMP message is called peer capability update notification message. Its format include a common head, a per peer head, and a peer capability flags, and a BP dynamic capability PTO. For peer capability flags, one bit is defined as T flag to indicate the direction of BP dynamic capability. When T is set to 1, indicate the BP dynamic capability PTO is received from peer. When T is set to 0, indicate BP dynamic capability PTO is sent to the peer. About its operation, if a new BP capability is added, outer all peer capability update are sent to the monitoring station. The route information and EOR of corresponding peer will be sent by BMP. If an existing BP capability is removed, only all the peer capability update will be sent, but the route withdrawal information of corresponding peer will not send by BMP. Another solution is define a new theory to report the BP capability update. This theory could be called a peer capability update notification subtheory. Besides, the available BMP message must include the corresponding BP peer address. Also, when must include RD when BP peer is associated with a VPN instance. The available BMP message can be peer up notification or generic event notification message. At last, we can discuss which solution is more likely to be accepted. Define a new BMP message to report the BP dynamic capability, or define a subtheory in peer-up message or in generic event notification message. Also, we need to request more review and feedback to improve this draft. Any comments are welcome. Thank you.
Hi, Changguang. This is Paolo. Speaking as a chair, there may be some merit in this work. I totally see it. So nice. But I think there is some overlap with the Jan message that Prasad was proposing, right? So I see that Prasad was proposing something to see whether you stop advertising something inside the session, and you are saying whether the capabilities are changing. So I totally see that there is some, merged, some combination that can be there, that can be done there. So maybe you guys should talk a little bit about it.
Okay, thank you for your comment. I'll see and reply by mail.
Sure, thank you. Maxence, please.
Hi, Maxence from Intellium. Can you go back 2 slides, please? I think at some point you were talking about the capability, the peer capability flags, right? I'm not totally familiar with the PGP dynamic capabilities draft, but there's only one flag where you say you either received or sent capability. Is it not possible that you sent the capability and also received it, or should you send 2 messages with that information?
In the BP dynamic capability draft, the capability context is included in BP dynamic capability PTO. The PTO defined is same as the BP draft. This capability flag defined here is to indicate the send or receive direction. The detailed context is included in BP PTO.
Okay. I'll go and read that draft then. Thank you.
Yeah, thanks.
Hi, John Scudder. The BGP dynamic capability draft that you're building on top of, it's more cooked than it used to be, but it's not really done. I mean, I guess it's good that you're thinking about how to track it, but it seems to me like it would be a little premature for the working group to invest a lot of effort in doing a design before the dynamic capability draft itself has stabilized a little bit better, I would think. I also have some more like detailed concerns about this, but I can do those on the mailing list if the working group decides to move forward with the work. But I guess mainly my caution is this seems a little premature, and also please consider very carefully what Paolo suggested. Thank you.
Yes, thanks.
Yeah, Paolo, I was just going to reply to your comment. So there were two options. One is to extend the gen message with this TLV, or to attach it to the peer up itself. I think that is what Isong was trying to ask the working group, which option may be preferable. Yeah.
Sure. Okay. Thank you.
Yeah, so it can go either ways. It can become an TLV within the gen, or if essentially capability today comes from peer up. So if the preference is we attach it as a TLV to peer up, that could be another option.
Thank you, Prasad.
Thank you.
Makes sense.
Can I? Hi again, this is Maxence from INSA Lyon. I'll be presenting the BMP SNTS, so sequence number, timestamp, and flags TLV. That's an update on the previous version we presented last time. So yeah, let's go. First, a reminder, because that's quite a new draft. The idea of this draft is to define timestamps types. So, for example, in BMP, you have some timestamp in the per peer header, but it's sometimes omitted. Sometimes the exporter cannot put the exact timestamp that's expected by the standard, and so you get another timestamp, like the time of export of the message, which is not what you're expecting to get. So the idea is to have a new timestamp, new TLV that contains this timestamp along with a type that tells you basically this timestamp is for the export of the message, is for the time in which the route has been installed in any of the 3 RIPs, stuff like that, right? Another TLV is the sequence number, which is always useful to have when you're having to handle streams of messages, and flags TLV to have a larger space for the flags and the new flags that we're trying to allocate, which seem to be running out. So quick updates on this the draft, like the changes basically. The flags TLV, we used to say that we are going to ignore flags in the per peer header going further, but some use cases were brought up, like for Luke Hendricks, right? Where they use those flags for hashing, and they like to have those flags at a static point in the message. So we've changed that. Now we do not ignore those flags. We just put them in a TLV, and you can still use the flags in the per peer header to do your hashing and stuff like that until they maybe one day disappear from that per peer header. We also changed a bit how the flags are. Currently, you have a lot of, you have 2 registries with different flags. Some of them are included in the other, but not in the same at the same bit. So, for example, the filtered flag. If we are going to have a larger space, and now space is not a concern, maybe we can just flatten all of those flags in a single registry. And so that's what we are proposing here. And also we just rename that flag TLV, because now it's not just the flags TLV, it's the extended flags. And then some other editorial changes. We've got, in the meantime, some feedback from the NJ that tells us, and he's 100% true, that we should not have this timestamp in the registry for route monitoring messages TLVs only. So I don't know if there's going to be a global TLV registry or if it's going to be a way where we have to allocate the ID in multiple registries. Either way is fine with us, to be honest. It's just we need to change that, right? And then we have a question for the vendor. So Job last time told us that the timestamp format we use, sorry, I should have put it again, but it's the same as the one in BMP currently. So it's U32 for seconds and then another for microseconds. That maybe we should go with timespec, which is a bit larger and gives you the precision to the nanosecond. We have no issues with that. We have maybe a question for the vendors, because I guess you're already recording timestamps, maybe as the format of the timeval, since that's what you export in BMP at the moment. So either way is fine with us. We'd just like some feedback on that. And then should we add some new timestamp types for agin and agout? For now, as of now, it's only agin and agout, and maybe we should specify agin pre-policy, agin post-policy, and stuff like that. Yeah, maybe you want to comment now or no? No, okay. Okay, so next draft is the lockrib peer address. This one is just trying to export the peer address in lockrib route monitoring messages, because it's kind of useful. Thing is that along the way we've added a lot of new TLVs in that draft, namely all the TLVs that tells you from which VRF you're importing, your route has been imported from, right? Those ones could actually be used in other RIPs. I mean, in route monitoring messages for other RIPs. So we've added like a section that tells you that you can actually use those TLVs in adribin and adribout messages. And that's it.
Jeff has on the TLVs. For the timestamp in particular, I have two comments there. The first one is it might be useful to get a survey from the router vendors to see how many of us are putting in something more than second level granularity.
Exactly.
Yeah, Juniper's implementation only really keeps track of seconds. Everything else is fake. Okay. But that also hits the second point, which is the current text you have is sort of asking some question about where do we actually put these timestamps in different types of events. And the goal is be very clear, and Tomas has made this point multiple times, be very clear for a given type what the timestamp means. That's at least one goal. And in some cases, there may be more than one time that you care about. One of the things we have heard from a number of our operators that are making use of this data is that they very strongly need the timestamp that's attached to the BMP record to have some level of meaning that this is a continuity in time. And as long as we're very clear what the continuity in time is for a given record form, so if rib-in and rib-out and lockrib mean different things, that's okay as long as they're clearly documented. If they have additional data that can go into the new TLV, this is also very good. But the effective requirement from at least my customers is that being able to use the existing timestamp and use that as a key in their database for continuity is their requirement.
Okay. Makes sense. Okay. Just one. Yeah, okay.
Hi, this is Prasad. I had a comment on this as well, Max. So I replied on the working group, but I am with Dhananjay's comment. We do see a need for sort of a generic timestamp TLV. In some cases, it need not be like rib view specific. It could be something generic because for such an event, maybe the rib view doesn't make sense. So that's one comment. And then are you asking if you want to make the timestamp bigger? Because if you remember last time we had discussed that there is an overhead of maintaining timestamp per path. So if any implementation is storing it, then anything with higher granularity means it'll take much more memory on a per route basis. So I think that goes with Jeff's comment that it may be good to do a poll, but I would suspect they wouldn't be doing this level of granularity today because it comes at a cost of memory and the scalability on the router.
Yeah, of course. I just want to add that the goal of this TLV is not to make you support like all of those types of TLVs. It's just that you can export any timestamp you already have stored, right? And tell us more precisely which one it is, basically. You can. If you support multiple, you can also export, add multiple TLVs.
Yeah, I was just commenting on point number 2 for the. I understand. Okay. Yeah, thank you. But
okay.
Yeah, for the granularity, I was just commenting that because it comes at a, maybe people wouldn't be doing too granular.
Okay, yeah. For the granularity, as I said, we don't have any preferences at the moment. We just reuse the one that's already in the timestamp. But I heard that you've sent an email. I'll also go and read that one. Thank you.
Hey, Maxence, just one minor comment. Just having a couple of weeks ago, the Young Doctors review on the Young Push envelope and the feedback we received, there is a new RFC 9557 on timestamping. I think we should consider that for the timestamp you are proposing. And it goes also along the same way. I think we need commonality among the different network telemetry protocols and also the kind of timestamping we are doing. And that's also the aim of that RFC.
Yeah, okay. So that RFC defines like types of TLVs, basically.
It's basically currently, I think the timestamp being used is RFC 33 something. And basically this RFC 9557 is updating. It has to do with time zones and so on. So I would go the same direction, but it probably doesn't answer the granularity part you're asking for.
Okay. Thank you. I'll have a look. Thank you.
Good. Thanks.
That's all.
Right.
But that is about an ASCII encoding of time strings.
That's about representation.
Yeah. So it's too large. You have to choose time vel or time spec.
And I think we have Mukul.
Yeah.
Yes.
Okay.
Floor is yours.
Yeah. Hello, everyone. This is Mukul here, and I would be presenting this draft, which is about EVPN related BMP RIB stats. I think this is the first time we are presenting this draft here. So this draft is, as we said, it is EVPN specific BMP stats, and this is defined for all 5 RIB views. Okay, so the format of this statistics is little bit different from what is in traditional BMP AFI-SAFI related stats. This is specific for EVPN address family, and the format would be, it will have the peer header followed by the BMP stats data, which is encoded into 1 byte for stats type, subtype, and 64-bit gauge. Since this is specific for EVPN type, we are not encoding EVPN AFI-SAFI in other BMP statistics message, which is AFI-SAFI based. So this is dedicated only for EVPN. The format type, the type currently which is defined is route specific stats. This is type 0, but probably I think this is typo. It should be type 1 probably. So this is the route stats, and subtype is all the stats which are route specific, and these are EVPN related subtypes statistics. Currently, this is the 3rd version which has been published. and there are some updates which is ongoing and will be published shortly. So as we saw in the previous slide, we had we have route type, stats type 1, which was route specific statistics. We are also planning to define types which are route agnostic and feature specific stats. Things like number of multi-homing Ethernet segments, number of multi-home EVIs, etc. So though that is work in progress. We would welcome any comments on this draft and would request working group adoption. That's all, I think.
Hi, Mukul here. I just wanted to comment. I think this is very useful. I like a lot that you're now also going down to the different route types, and especially that you're well aligning with the IETF Young module, what's being exported there. Thank you very much.
Yeah, thank you. Okay, I think that's all.
Thank you, Mukul.
Yeah,
we don't
thanks.
have anybody else in the queue here. All right, we have 5 minutes. Any open mic issues? Anything anybody wants to discuss? Jasper, maybe?
Hi, Jasper Hertog, NL Labs. I had a question/discussion point for the draft that is not presented today about the filtered adjacent rip in and out draft. That specifies a Boolean to indicate whether the rip view was filtered, and a free form field with a meaningful string. I asked my colleague Luc to react on the list to say, like, couldn't we do this in a little more structured way? And there was sort of discussion around this, so I would like to elaborate on this. My idea is that we could keep it really simple and add a few flags, like one of my pet peeves is like the difference between a filter and a filter map. So if you are actually transforming stuff out of your rip view, then that's not an actual filter, but a filter map. And I would like to know if you're doing that. And the other issue is that, like, in a filter, it would probably also super helpful for people looking at the monitored rip views if they knew if this was an exclusion filter or an inclusion filter. So, like, are you filtering out certain fields, or are you only showing certain fields? I can see, do you want to filter on not showing certain pairs in the rip view or only certain pairs? And then even you could still have the meaningful string, but the string would be an indication of what you're including or excluding. But the fact that if you have like an extra flag that says it's an inclusion or an exclusion filter would be, I think, super helpful.
Jasper, Jeff Haas. I'm not the implementer. Mukul on the phone is, and I am not going to put him on the spot. But we do some level of filtering on our stuff. The problem you're talking about is when it comes time to tell a receiving BMP receiver, what are you actually filtering on? There's no way to boil down a large amount of potential policy into anything that's trivial to be digested in the protocol. And we see this in many places in IETF, like picking on our RPSL as an example. There's no easy way, even with that abstraction, to cover every single thing that you could do in these sorts of things. And policies that we're seeing from our customers are varying from the very simple, send me a subset of the AFIs. Send me a subset of prefixes. We have requests for doing more general, here's an actual policy filter, give me the routes that match this filter. So when you have these sorts of things, it's not going to fit into several hundred octets worth of anything besides a name. The best we can do is maybe like a policy name, and then what does your implementation do for this thing? So I don't think there's a good answer for you.
Camille Cardona, sorry, I closed the queue.
Please.
And I will say that in the YAM module, we're trying to have those filters at least so that you can check them at least from the configuration side of things. But I follow Jeff that may be too much, but we can always explore, I guess.
All right, we have reached the end of the show. The advertisements will start any moment now. We'll see you at IETF 125 in China, hopefully. Thank you for your contributions. Thank you for the slides.
Yeah, well, kind of from
Oh, wow. Wow.
This is legal? I'm not sure. You can try to burn.
All right. Chili powder.
Okay, but kind of, if you like it, just I can burn it. Or
I hope
kind of enough operation.
The next time
Yeah, it's good, sure. Yeah, one of my, I know and kind of asking you that question, of course, in respect. I remember that you for many years before it's done, I started